Revolutionizing power, the role of steam engines in energy generation. Welcome everyone. Today, we're diving into a fascinating topic that has played a crucial role in shaping the world we live in, the steam engine and its impact on power generation. From the smoke-filled factories of the 18th century to modern power plants, steam engines have undergone incredible transformations. By the end of this presentation, you'll have a new appreciation for this technology and its significance in our energy landscape. Let's get started. The history of steam engines, early steam engines. Narrator. Let's begin with a brief history. The steam engine is one of the most important inventions in the history of technology. The first full-scale working steam engine was invented by Thomas Newcomen in 1712. This early design was primarily used for pumping water out of mines. James Watt's innovations. Narrator. In 1765, James Watt made significant improvements, introducing a separate condenser, which greatly increased efficiency. Watt's enhancements allowed the steam engine to be used in various applications, including locomotives and ships, hence powering the Industrial Revolution. The Industrial Revolution, the impact was colossal. Factories could operate machinery that would have previously required manual labor, leading to an unprecedented increase in productivity. Transportation, too, transformed dramatically. Steam locomotives slashed travel time and opened new trade routes, which ultimately reshaped economies and societies. Mechanics of steam-powered gen, how a steam engine works. Now, let's delve into the mechanics behind steam power generation. At its core, a steam engine operates on a simple principle. It converts thermal energy into mechanical work through the principle of heat expansion. Components of a steam power plant. A modern steam power plant consists of several key components. Boiler, where water is heated to produce steam. Turbine, where steam is directed to rotate blades, converting steam energy into mechanical energy. Generator. In this part, mechanical energy is transformed into electrical energy. The Rankine cycle. The operation of these components occurs within the Rankine cycle, a thermodynamic cycle that describes how steam engines operate. It consists of four main processes: isobaric heat addition, isentropic expansion, isobaric heat rejection, and isentropic compression. The efficiency of this cycle is crucial for power generation. Types of steam power systems. There are different steam power systems, including fossil fuel steam plants utilizing coal, oil, or natural gas. Nuclear steam plants, generating heat through nuclear fission. Geothermal plants, harnessing natural heat from the Earth's interior. Let's begin with a brief overview. A steam engine is a heat engine that converts steam's thermal energy into mechanical work. Understanding a steam engine involves not just its mechanical components, but also the physical principles that govern its operation. History of steam engines. To appreciate the steam engine, we must first consider its historical context. The concept of using steam to produce power dates back to ancient times, but practical steam engines emerged in the 18th century. The earliest steam engine was developed by Thomas Newcomen in the early 1700s, primarily for pumping water out of mines. However, it was James Watt who, in the 1760s, significantly improved steam engine efficiency by introducing a separate condenser. These advancements laid the groundwork for the widespread use of steam engines in various industries, from mining to transportation. The steam locomotive, which utilized steam engines to propel trains, revolutionized travel and commerce, enabling goods and people to move faster and more efficiently than ever before. By the late 19th century, steam-powered ships, locomotives, and machinery had become ubiquitous, fundamentally changing society. Basic principles of a steam engine. Now that we have a bit of historical context, let's delve into the basic principles behind how a steam engine works. At its core, a steam engine operates on the cycle of heating, pressurizing, expanding, and releasing steam. The primary law governing its operation is the thermodynamic principle, which states that energy can neither be created nor destroyed. Instead, it changes form. In a steam engine, thermal energy is converted into mechanical work. This cycle can be illustrated by what is known as the Rankine cycle, which involves, for main processes, heating the water to generate steam, expanding the steam to perform work, condensing the steam back into water, and reheating the water to continue the cycle. Components of a steam engine. Let's explore the main components of a steam engine and their roles in the operation of the machine. Boiler. The boiler is where water is heated to produce steam. It typically consists of a large tank or chamber with heating elements, often fueled by coal, wood, or oil. As the fuel burns, the heat generated converts the water in the boiler into high-pressure steam. Proper maintenance of the boiler is crucial as it operates under high pressure and can be dangerous if not managed correctly. Steam cylinder and piston. Steam produced in the boiler is directed into a steam cylinder. Inside the cylinder is a piston that can move back and forth. When high-pressure steam enters the cylinder, it pushes against the piston. The piston's movement creates mechanical work, which can then be converted to rotational motion. After the steam has expanded and pushed the piston, it is released through an exhaust valve, usually into the atmosphere or back into the boiler, depending on the design of the steam engine. This exhaust process allows fresh steam to enter the cylinder for the next cycle, keeping the engine operable without interruption. Control mechanisms. Many steam engines also feature control mechanisms, such as pressure gauges and valves that regulate steam flow and pressure, ensuring safe and efficient operation. Working cycle of a steam engine. Now that we've outlined the components, let's walk through the working cycle of a steam engine step by step. Generating steam. First, water is heated in the boiler until it converts to steam. As pressure builds, the steam is collected and is ready to enter the cylinder. Entering the cylinder, the high-pressure steam is directed into the steam cylinder behind the piston. This steam pressure is what propels the piston forward, showcasing the transformation of thermal energy to mechanical work. Piston movement. As the steam fills the cylinder, it begins to push the piston. The piston moves from one end of the cylinder to the other, turning the crankshaft connected to it. Exhausting steam. Once the piston reaches the end of its stroke, the exhaust valve opens. The steam that has done work on the piston is released, creating space for new steam. Cycle repeats. The cycle is continuous. The next burst of high-pressure steam enters the cylinder, pushing the piston back in the opposite direction and repeating the process. Types of steam engines. There are various types of steam engines, each designed for specific applications. Let's briefly touch on a couple of important types. Single-acting engine. In a single-acting steam engine, steam is applied to only one side of the piston. The return stroke is usually aided by a spring or atmospheric pressure. This design is simpler but can be less efficient. Double-acting engine.